Hello, everyone. This video continuously explain the questions on practice exam 2. Okay, so now for question 25, and then let's see what the question is asking. Okay, so that's asking us a percentage by mass of nitrogen, a particular atom from this compound. Okay, so now again, mass percent is a quite straightforward concept. If you wanted to calculate the mass percent of certain atom from that compound, you need the mass of the particular one and divided by the total mass of the whole compound times 100. Okay, so then that's just how it's gonna work. Okay, so now let's look. We're working on nitrogen. How many nitrogen are there? Okay, so now that's the part, right? So if you look at this nitrogen, you go, oh, only one. I look at the chemical formula, but you have to understand that is inside a parenthesis, so that two also describing, right? You have two of that nitrogen. It's not therefore, okay, two. They go, oh, what's this mass? I don't know. It's not given, right? Okay, but then again, we can simply use the AMU, or right, numerically equals to grams per molar mass. Okay, so now I'm just going to use AMU again. Like I said, numerically it's the same number from the periodic table. Okay, so it's 14.067 AMU. Okay, so now I'm going to divide it by the total mass of the whole compound by adding everything up. Okay, so then we'll have 195.078 plus 35.453 for chlorine times 2, and I'll put into the parentheses. Right inside here I have nitrogen, which is 14.067 plus 1.00. You can use 794 or use 1.008. That's fine too. Okay, so multiply by 3, then multiply by 2. Okay, then I'm multiplying by 100. Right? Okay, so now that's finish of the calculation. The mass percent for nitrogen, that'll be 9.34%. Okay, so then that's just how to calculate the mass percent. Now let's look at the next question. Based on this question, let's see what's this question about. Okay, so we're asked to solve sodium ion. Okay, and then let's see if this compound itself given is sodium sulfide. Okay, so then we go, okay, I have a whole compound and then I'm given with the mass of a base. So I'm looking for a specific ion from this compound. Then let's start to work on that. Okay, so we're gonna start with, right, we have milligram, the plan. Okay, milligram of this whole compound. We're gonna turn that into gram. Okay, so from gram by using molar mass, we can get 2 moles of this compound. Okay, and from moles, now we can turn this into moles, number of the compound. Okay, and from the number of the compound, we can get to number of the sodium. Okay, so now that's the plan. Let's start. Okay, so with given milligram, that's straightforward. Okay, so it's 99.6 milligram of this Na2SO3. Go to gram by using the relationship between gram and milligram. Okay, so 1 gram equals to 1,000 milligram, or 10 to the power of 3. It's the same thing, right? Okay, so now use molar mass of the whole compound. That question is nice, it's given to you, so we can directly use that. Okay, so it's every 1 mole of this sodium sulfide will weigh 126.05 grams. Okay, that can tell I got 2 moles. Okay, and then from moles to number of that compound we use Avogadro's number. Right? Okay, so it's every 1 mole of this compound will have 6.022 times 10 to the power 23 of this whole compound. Okay, and then the last step is we want to know just sodium itself. So then we need to look at the chemical formula and see what's the relationship next. So it's every 1 of that sodium sulfide has 2 of that sodium ion. Okay, so now we finish the setup and then we can get to the final answer. Okay, so the final answer will be 9.52 times 10 to the 20 sodium. Okay, so then that's that. Okay, so now let's look at the next question, determining molecular formula based on info. Okay, so now we're given with the molar mass for the whole compound. We'll know what's this molecular formula, and we're given with the empirical formula itself. Okay, so now you go, what do we do? Okay, so this is the relationship such as you have, as I said, jelly bean. So you have a bunch of jelly beans, you don't know how many, but you know its mass. So how do you figure out how many? One way is that we can, right, we know the mass of this whole bunch. We can measure one of them and see what's the mass. Then we do a division, and then we see how many of that jelly bean will have the similar idea. Okay, so we know the total mass over here, right? So now we want to know each jelly bean, right? What's its mass? And if we know each jelly bean is this chemical formula, and then what's the mass will be, right? So let's figure that out first. Okay, so then we're gonna calculate the molar mass of this C2H5O2. Of course, we can get the numbers from periodic table and calculate the molar mass, comes out as 61.0491 gram per mole. Okay, so again, think about it. Each jelly bean weighs that much, and let's say how many. So we're gonna calculate the number of these units. Okay, by using that molecular molar mass divided by this empirical molar mass. So that'd be 183.2 gram per mole divided by 61.491 gram per mole. Okay, do this division, we'll get 3. So now we'll have 3 of these jelly beans. Right? Okay, so what's the formula will be, right? So that'll be C6H15O6. Okay, so then that's how you solve this question. Okay, so now let's look at question 28. Okay, so for question 28, it's asking us to determine empirical formula. As always, we need to know what that is. Okay, so X, Y, and Z, these are, we're looking for the smallest whole number mole ratio. Okay, so if we're looking for moles, then you go, oh, I'm only given with percentage, and only 2 of them. You go, no, what do we do? Okay, so now, as I said, if you want to know moles, if you only give percentage, really, we cannot really work on it. Okay, so then what can we do is that assume you have 100 gram of that sample. Okay, so now we're gonna do that. Okay, so I'll assume we have 100 gram of the sample. So then therefore the percentage simply turns into grams. Okay, so now I'll know I have 52.14 grams of carbon. I have 34.73 grams of oxygen. Then what about hydrogen? What about hydrogen, right? If we know inside that compound we have carbon, hydrogen, oxygen, I know 2 of them, so I can calculate the last, right? Okay, so the mass of, I'm gonna use different color. The mass of hydrogen simply should equal to 100 gram minus that 52.14, and then subtract the 34.73. Okay, to this calculation, we'll get 13.13 grams of hydrogen. Okay, so remember, we wanted to know moles. We're given with grams. So then what do we do? Molar mass, right? Okay, so now let's calculate for carbon. Okay, so for carbon is 52.14 gram of carbon. Use molar mass, which is 12.0107 gram per mole. Now I get to the moles, give me 4.341 moles of carbon. Okay, and then can also calculate for oxygen. Okay, so oxygen will be 34.73 grams of oxygen. Okay, that's 16, or you can use 15.9994. Okay, so grams per mole. You should get around 2.1707 moles of oxygen. Okay, and then we can calculate for hydrogen. So that's 13.13 grams of hydrogen. Every 1 mole is 1.00794 gram. Okay, so I get 13.0266 moles of hydrogen. Okay, so now I'm going to write down the pseudo formula. Okay, so which will be carbon is 4.341, hydrogen is 13.0266, oxygen is 2.1707. We divided by the smallest number, which will be at the most of the oxygen. After we do the division, we get an empirical formula, turn into C2H6O1. Okay, so then of course if it's 1, we don't write it out. Okay, so that's that. Okay, so now let's look at the next question. Okay, so then the next question is asking us, okay, so what volume of a concentrated solution of the sodium hydroxide must be diluted to that and making this solution? You know, that sounds pretty easy, right? Because that's just simply what? Dilution problem. Okay, so if it's a dilution problem, well, how we can solve it? We can simply use M1 V1 equals to M2 V2 as long as you plug the information correctly. Okay, so now let's see what information I meant. Okay, so from this question, you're asked to calculate a concentrated solution of sodium hydroxide, which is 6. Okay, just on the left, I'm using my concentrated one. So then the concentration is 6, and then we're looking for the volume. Okay, so now what's on the other side? That's about the diluted solution, and you have this 3.23 molar times 185.6 ml. Okay, and now let's just solve that V1. Okay, so then the V1 will simply equals to, right, that number, I'm going to copy it, divided by this 6. Just pay attention to the unit, and then we figure out the molarity all cancel out. We just have ml, and then that is the unit of the question is asking. So that's perfect. Okay? So now you get to the answer is 99.9 ml. Okay, so then that's for this question.